This discussion pertaining to the evolution of data in terms of data storage, data processing, data consumption, the technologies which have been driving the trends and the adoption, etc. My name is Guru Shankar, and I'm going to be anchoring this discussion today. And I am getting to do what I like the most, which is asking questions. And the questions that I'm going to be asked are going to be responded to by my very good friend, Pattaviram. Just to give you a context, between the two of us, we share almost 40 plus years of IT experience in the industry. And Pattaviram is pretty much the subject matter expert where data is concerned. That said, let me give you a little bit of a sense as to what we're going to be discussing. Data is a new oil, data is a new diamond, data is a new platinum, so on and so forth. I've been hearing these kind of fancy phrases for well over a decade now. But truth be told, data creation, data processing, data consumption has undergone a sea change in the last decade or so. Gone are the days where the data was extremely structured. The RDBMS as one way of essentially creating, processing, and consuming data. Now we have a whole gamut of data sources as well as formats. We have structured data, we have semi-structured data, and then we also have unstructured data. And similarly, there has been a huge growth, rather I would say a leapfrogging has happened in terms of the computational power as well as the storage capacity where data is concerned. That's the other dimension. And the third dimension is about the consumption of data itself. Earlier, the data used to reside in a specific database, and then somebody extracts the data and then does some basic analysis on it and then reports it out. But today, the advent of machine learning as well as AI has pretty much redefined the way processed data is actually consumed in multiple forms. So that's kind of how we're going to look at it. And some of the key topics that we're going to pick up are one is data products. That's something in the last couple of years I've heard quite a bit, data products. Other thing is also we have essentially known what is called as data lakes. But in the last few years, data lakes has been or is being slowly replaced or maybe is giving rise to what is called as the data. You had boathouses somewhere in the lakes, but now we have data lake houses. I don't know what that exactly means. So we're going to find all this out. Then let me hand it over to Pattaviram. Pattaviram, please go ahead with your opening remarks.
Thanks, Guru. Yes. Before I start our journey, I'll try to focus the discussion on the finance domain, and then we'll touch upon the other domains.
Okay.
Past two decades, you see, data has evolved from gigabytes to petabytes. From business consumption angle also, there is a lot of evolvement where initially traditional slicing and dicing of reporting is there. Now, there is a requirement where you want to do a real-time reporting. Typical reporting scenario will be to do your balance sheet reporting. There is some sort of the customer segmentation we will be doing, which can do a targeted campaign management. So these are all traditional slicing and dicing requirement. But then there is a ever-growing need for managing the unstructured or semi-structured data came into play. Their data warehouse was not flexible because it is a schema governed type of model. So it is not allowing semi-structured data to handle. Second, the storage has become a major concern. The storing of a traditional data warehouse is much, much costlier. That is where, if you see, data lake came into place, where the focus more on how to make my storage cheaper. Okay, I have a gigabytes of data. Now it has gone into terabytes of data. Can I do it with the 20% of cost what I am spending on storage? Data Lake was able to address those scenarios where it is where the storage was much cheaper, and it also able to cater your semi-structured and unstructured data storage, which you combine with the structured data, you can do a lot more into the analytics space. I'll take an example of fraud detection. Initially, fraud detection, mostly it is focused on structured data. Now, if I can gain an insight into my customers' social media or other interaction, when a transaction is originated, can I identify is it originated from a country or person who is politically affiliated? Those sort of meaning was not possible before. Similarly, there are a lot of market deposition happening between each country. There is a trade war ongoing. So can I try to immediately understand what are my liquidity position or what are my risk weighted asset instantly and able to take a well judged call. That is where data lake was able to address. But data lake has some inherent deficiency. One, it is not enforcing a schema rigidly. That is what I say is you will have a structure, but schema enforcement was always not a data lake's main goal. Second, ever after 2009, where bank crisis has happened, there is a ever growing need for a data governance was there. So you
Right.
need a data where you are sending your regulatory reporting. I'll take an example. You send your cash flow and the balance sheet to the regulators. In another case, you are going to pledge your collateral information to the regulator. Whether both speak the same truth, that the data integrity is where now become more important and data security. Data lake as an inherent problem on the data quality side. So two aspects. One, data quality side. Second, your traditional reporting, you are not able to achieve through data lake. Even though it supports both structure and semi-structure, there is always a performance issue when you do your structured data analysis. The compute capacity also become a problem. So to address all this is where your Lakehouse concept came into picture. When I say Lakehouse concept, what best of both worlds, like supports your structured data with the slicing and dicing, schema enforcement of data warehouse, and then it takes the storage optimization of your data lake where you can do your advanced ML use cases. Data Lakehouse introduces a concept called shared nothing architecture that decouples your storage and compute. So I can
Can you repeat that? You said what is the name of this architecture? Share?
shared nothing architecture.
Share nothing. Okay.
When I say shared nothing architecture, I have created my data. Okay. Now, if I want to say in the bottom, if you see, I have created a top down. I have created say 20 or 30 data products. Bottom, I have more than 20 or 30 different use cases are there. Can I run all the use cases without impacting each other? That is where you call as a shared nothing architecture. Oh, the data strategy evolution, what I was trying to say is what went it and how we transformed hope it addresses your initial queries.
Yeah, that's right. I think this kind of opens up the topic of data strategy because we started from the traditional RDBMS and then we had data lakes, as you mentioned, and there were use cases around data lakes. And you also spoke a little bit in terms of what were the typical constraints that data lakes had. And with the evolution of technology, be it on the storage power front or the computational front, things have moved. And obviously today, the demand in terms of the way process data is consumed has actually changed completely from what it was a few years ago. So now you're saying that data lake house is something which is beginning to address some of those inherent deficiencies, you can call it, where data lakes are concerned, including the age-old problem of the single source of truth or data governance, data quality, which are the typical challenges which any enterprise will be facing around humongous volumes of data. Let's move on.
Okay. I'll touch upon design consideration. Now we have talked about the challenges and data strategy evolution. So if I want to ideally build a platform that can address all my design consideration, let's look upon some of my design consideration. So I created a data. Is it master data that I can have all my consumption system consume it and share the same truth? That is key design consideration now. Second, moving from a centralized ownership to a domain ownership, because a particular domain, they have a product owners will have more knowledge on how to consume the data than the technology driven. So it is slowly moving from technology driven to business driven. So my design should cater to that.
Okay.
I need to have a enrichment layer. Once my data is there, I need to have an enrichment and data sharing layer where my enriched data can be shared across all my downstream system. You should have a scalable architecture. What I say is, I do have, say, 10 or 20 application that is running with each with the 50 terabytes of data. And I have a reporting nets where 40 or 50 concurrent users are rather you consuming the seat of these applications. So then I need to have a massive infrastructure where it should be scalable. That is, when there is no load is there, it should auto scale down. And when the load is there, it should scale up automatically.
Okay.
Then data masking requirement is another key. Now the data governance is coming into more picture with a lot of the regulatory concerns on the data privacy. So to my design cater to managing the customer data as per the governance guidelines. So these are all the key design consideration we need to take care of, which will address all my consumption needs, the evolving consumption need. At least this is how we need to first start what is needed, then we'll go into the how part. Any questions on that?
I think more than a question, I think what has caught my attention in the last 5 minutes is that you said in terms of data, we are moving closer to what you defined as the domain specific data. I think that's something which is an important change because I've been in scenarios where we have thrown multiple technologies, multiple storage media, etc. at business, but then and we also done many things to support the business in terms of scaling data, the way they're going to consume, etc. But at the end of the day, the insight as well as the esoteric knowledge of the why, what, how, and when of data obviously resides with the product owners or the business owners. Okay. I think that's important. For example, I've had the experience to work with inventory departments of some of the large organizations, and the kind of insight that they provide is something which the IT team can never have because they do this for a living. I think that's an important shift. Let's move on.
Yes, you nailed the point because
Mhm.
when the data is with the product owners, then they will know what are the consumption thing they need, what is the underlying data they need to build. They will have a full clear idea of what sort of solution they want to provide to the end users. And also the evolving market condition, can they be agile? So the ownership is better handled if it is with that domain instead of centralized ownership, if it is specific to the domain ownership. So key theme of data product is moving away from centralized to a domain ownership. Then the product journey starts with the data discovery phase, where domain product owner will see, okay, what are my business requirements and how do I need to be more competitive in the market? So they will first go and do a discovery phase on what are the data points they want to keep it in the data product layer. Then start from that, create a lineage, then start consuming the data. Second part is now I have created my data. How do I make my data always have a strict integrity that whenever multiple system access my data, both on the time in which it access the data and also when the report is shared to the key stakeholders and regulator, does it speak the same integrity truth? That is also this platform will need to provide. Quality and observability is what I say. Third is security. Now my data is there. The data transfer can happen across boundaries because most of the multinational banks, they will have presence in multiple markets are there. So I need to make sure my data governance layer is in place. I created my data and I'm going to share with customers which are global. So I need to make sure my data compiles to all the data regulation across different countries. Last is the privacy. Now the ever growing demand of the data privacy is there where, see, not only how long you can go, store your customer data, but are you storing for a specific use case is also becoming more and more the norm. So this data product layer will address that part also. This is a high level, what I say is a key ingredients of data product. It adopts the data mesh as a architecture principle, and then it addresses all these qualities.
So what we're essentially saying is this data product, contrary to what I was thinking, it's not really a product from, let's say, an Oracle Corporation or maybe it's from a Sybase kind of thing, but it's more in terms of package, which is done in the software part of it. Then let's come to that link later. But essentially, it's a package which is going to have multiple layers. One is the actual core data itself. And then you put on top of that specific data layer. Obviously, these are use cases. I took an example of inventory, or it could be from purchasing, it could be from finance. There's a purchasing manager who wants to have a specific data product around procurement, for example. And I think he or she is going to have the actual data records itself. And then on top of it, you also have a layer around data governance. And then you also have a layer as to how you establish and verify the integrity of this data coincidentally, the data consumption happens in an enterprise also using microservices, API calls, and whatnot. So, and above all that, you also have the compliance requirements. Essentially, if I'm going to take an example to the GDPR requirements in Europe, for example, in terms of how you protect privacy of data and so on and so forth. So, a data product is essentially a package having multiple layers, which can be consumed in a very, very uh, controlled way, if we can say so. Does it make sense?
Yes, yes, absolutely.
Okay, all right. Let's keep going.
So, okay, probably what I'll do is now we have discussed on what is the data strategy development is there and need for creating a lakehouse and data product architecture. Now we'll focus on a specific finance use case.
Sure.
Say, I want to build a system in finance where I want to address both my traditional reporting needs, slicing and dicing needs, and also the advanced ML scenarios. So what are the data I need to build? As I said previously, data discovery phase comes into the picture. So
Okay.
key, what I say is there is a two types of data product normally that will be created for this sort of needs. One is a standard data products. This data is mostly sourced from the transaction system. You create a loan
Okay.
or create a savings account. There is a asset class what we call is a product that is created. Loan is a
Right.
product, and current account or savings account, securities, each of those are products. So one is
Products. Okay.
product level information.
Mhm.
Second, my customer base. It can be a retail customer or a private banking customer or an institutional customer. So I need to have an end-to-end view of all these customers and their attributes.
Okay.
That is my facility. So what are the facilities I do have? One, the facility can be within the institution or some of the collaterals we are getting from the loan origination. So this facility information is also a critical thing. Then I do have all the data. I need to know how each of my branch is doing. What is the performance of my branch in Chennai versus my branch in Korea or something. I want to have a region or territory wise split within that. Then you'll have
Okay.
our master ledger. All your data needs to your asset and liability needs to reconcile. So ledger is
Okay.
another critical information. So you identify all the standard products, you built it. Then there is another requirement is there. We are talking about the source, standard products, and consumption layer. There is a middle layer where there are engines that calculates your derived data products. I'll take an example of risk weight assets. When I say risk weight assets, I need to classify all my assets based on that risk exposures. See, if I am holding a cash, there is no risk related to me. But if I am going to loan a customer who has a, say, mortgage risk asset, then my risk exposure is less. But if I'm going to finance my institutional customer, then my risk is much more. I need to go into the ratings and other things. So there is an engine that calculates your risk weight assets. Similarly, my cash flow. Your market rate risk is always there. I say trade war is going on. No? Suddenly some sanction is imposed. So what is my cash flow impact based on that? I need to derive that. That
Okay.
you always see customer comes to the bank loans it. What is the profit bank is getting? Within the bank, you have a treasury business is there. What bank does
Right.
is this? Within the bank, branch gets the money from treasury and treasury will charge them some interest on top of that. So what is the profit each branch is providing? That is what you call as a transfer pricing. There are, so as I said, no multiple loan to value is there. What is mortgage loan? What is its current loan? I need to know because when I given it might be 120% of what the customer is asking my loan. Suddenly it might have come down to 80%. So I need to know that. So this is the derived data product your engine is calculating. So you establish your top layer where you created your standard data products and derived data products. Then comes the consumption in the bottom part, where you do a traditional reporting, where you send a balance sheet report to your regulator. What I call is a IFRS reporting. You have a mandate to send your balance sheet to the regulators. You also have internal treasury reporting, where I want to see how do I improve my performance? What sort of concentration I need to do? Can I need to focus more on my private banking or retail mortgages? This treasury reporting gives a clear insight. Then
Okay.
on grail of customer 360, where use the full gamut of customer information. You can do your traditional customer segmentation or fraud detection using customer 360 degree. This is more on your what I say is slicing and tracing of the requirement. Then you have a advanced machine learning or deep learning scenarios where I want to do a fraud detection. I do have a customer. If he has originated this transaction on a country that is in the sanction list, then I shouldn't sanction that transaction. I should stop the transaction. Or if the customer is a fraudulent customer, which I can know from the transaction pattern, suddenly the customer might have done a transaction of say 50K or 100K. Suddenly, you see a transaction that is originating 1 million that is deviating from its normal transaction. I need to identify the transaction instantly and alert the customer. Those sort of advanced real-time which the structure and semi-structure needs committed flow. Second is a cash flow optimization. I do have a cash flow. What if there is a stress scenario in my bank? How do I manage those scenarios? Is that I need to do to address those needs? Can I pledge my existing underlying loans to the regulator and get the money back? How do I improve my cash flow based on different trends? Can I do instantly? Those sort of need is what data products addresses. So as I explained, you define a product, then you address the consumption needs and make sure all your consumption needs are running in parallel without impacting each other.
All right. I think that was a lot of information that you packed around 3 or 4 different ways in which data is consumed in a banking situation. Okay. So what we are essentially saying is there is going to be the actual data record which is residing somewhere. Okay. And these data products essentially provide very specific, very targeted insights into a slice and dice of data for specific use cases. And in this case, enable banks to make informed decisions rather than going and looking at multiple places and trying to figure out essentially spend time trying to extract data from somewhere and do many of these operational things which are not really useful. We already have provided a whole bunch of decoupled data products, which would look at the data, look at some of the patterns, and then obviously the technology kicks in, and then we are in a position to make informed decisions and then take things forward. So to me, I come from an application background, not from a data background. So it looks loosely to draw an analogy. It looks like it's getting much componentized, if I can use the term. For example, you have an API, you have a specific set of business logic defined in an API, which is Cocoon. And whoever needs or whenever it's needed, those API get called. It seems like what's happening in terms of these. It could be API calls, microservices, etc. Yeah, that's the analogy I'm trying to look at to make decisions and take things forward.
Yes.
Okay.
Yes.
I'm looking at it.
You nailed the point because yes, data is also going to more what I say microservice sort of architecture. You have a data product. Now you have a consumption layer where it can address your real-time needs, which can be a pay call or it can be a traditional batch reporting where you need to do terabytes of processing. Yes, it addresses both the needs. That is where infrastructure comes into picture. If I go into the right side, there are two different ways data lake addresses needs. Where you have a, say, I'll take a type. Now we are in the Indian time zone. Probably I'm coming from a East zone time frame where most of my queries are transaction will originate on the East zone time frame. But there are customers, there will be transaction that will be happening in the India time zone. So there you will need a system which can vertically scale up. But there are cases where you need to do a batch processing, where you need to do a horizontal infrastructure scaling. When I say vertical, I'll have a small CPU, then same replica of CPU will be added. When I say horizontal coupling, you go into from say, 10 CPU to 20 CPU. Those both sort of flexibility will be available in your shared nothing architecture, where you can do a vertical scaling, you can do a horizontal scaling, you can do a container sort of approach as you are suggesting. Most of the products that is coming up with the data product structure.
Okay. Yeah. So if you can hold it also right there, right? This is an important topic for us because obviously most of the enterprises are going to expend a lot of money around infrastructure. And every time we have discussions in terms of technologies, we can do this, we can do that, etc., etc. At the end of the day, they're going to hit the bottom line and keep asking two or three cliched questions. Total cost of ownership, licensing in terms of these products, in terms of the storage products, as well as ROI, and how can they drive down the cost? Okay, if you can give me one example, maybe if you think it makes sense, maybe can you give an example in terms of are you talking about hyperscalers or anything like that from Amazon or something? How does this really happen? If you have data products, if you have the actual data is sitting in ERP systems or Salesforce systems, etc. But then they're building these data products, and then you need a huge capacity in terms of processing this and that's where the infrastructure piece or cloud, etc. kicks in. So if you can give me an example, that will be a little more insightful for me,
Great.
for everybody.
Yes. Always the end user question will be okay. You are building me a solution. What is my return on investment on those solutions? So Lakehouse goes on three different concepts. Storage optimization. It has a format which is open source format for storage. That is
Okay.
the Data Lake, Apache Iceberg, Parquet. These are all the open source formats where it can be leveraged across multiple systems, and the cost of the storage is much cheaper. What I say is, if you have a traditional data warehousing where your cost is say, I'll say $100, this will be either $15 or $20, one fifth of the what is the cost in query. So that is the
Oh,
first
okay.
thing. Storage wise, you are trying to minimize your cost. Second, capability wise, can I do a real time integration? Can I want to do a streaming data or batch data? It has all the technology components that comes with the platform, which are more open source. It can leverage PySpark, or it can
Okay.
use inbuilt SQL engines, streaming services, which are coming inbuilt within the platform. So the platform itself comes with all these packaged technologies that can reduce your
Okay.
cost cheaper. Then it
Okay.
has a governance layer into that. So that case of any violation or something that always incur a cost. You build a solution, but if it's security or regulator page, you will have to incur a lot of cost. Since the package is the solution is packaged, you don't need to worry about your technology depth. That is again the cost is coming down. Hyperscaler, as you suggested, when need, say if I have only 5 users consuming my system, I'll go with the lowest capacity need, probably 4 CPU or something. Then when my customer is transaction getting say 10 or 20 times more, I increase my 4 CPU to 16 CPU. Again, when the transaction become normal, I'll scale down. So that's flexibility infrastructure will also come down. Yes, your one-time cost of building a solution which will be little high, but your
Mhm.
year-on-year cost will be much lesser when you start building this solution where it will be, say, I'll say 20% or 30% your year-on-year cost will come down. That is
Okay.
the
All
beauty
right.
of implementing this Lakehouse.
Let's double click that and kind of look at the technology part of it. Okay. Because we've been talking about data lakehouse, but what are the whole set of tool sets and technologies which are in play at this point?
Yes, that is a key part. So now a lot of industry players have come into picture. You have from the Databricks, you have a Lakehouse architecture. Now Click has done a lot of acquisition and they also have a whole gamut of architecture. Then you have Snowflake, which is an industry leader. From Google, you have BigQuery is there. Amazon has a Redshift. So all the major players have technologies and stack that can cater to the Lakehouse. But if you go to individual components, you need a streaming services, data pipelines, that that will be
Okay.
coming with the platform. Then you need to have a format that supports your storage optimization, like Apache
All right.
Iceberg or Data Lake. Try to use
Mhm.
as a source, like using PyDB. Then
Okay.
comes your consumption part. You can
Mhm.
easily integrate your data products with the tools like TensorFlow or PySpark or SageMaker, which can do your advanced analytics processing. Yes. Then you also have a data visualization need where you can connect your data platform to a Tableau or ClickView or Power BI. ClickSense, where you can do a slicing or the dicing of requirements. So whole gamut of technologies that are available, and most of the industry players are already adapted to this.
That brings to the next question. I think this is extremely important because I never knew about some of these tools. I just knew about Databricks a little bit and maybe being a away from the data technology. But I think this helped me understand what each of these vendors are actually coming up with. I will remember this for sure. The next question from here is, given your experience in liaising and collaborating with various clients, how is the trend where the adoption of this whole new set of technologies is concerned? Initially, that could be the sales pitch initially, and then opening up the hood saying that these are 20 different things that you can do with this set of tool sets. This is where the industry is going toward. But then the actual proof in the pudding comes with them adopting or willing to make an investment in many of these things. What's the trend that you observe, right?
See, most of the financial healthcare sectors are already into the data products or Lakehouse adoption journey, or they are into the near what I say, mostly they are advanced state of it. Either they are in the initial stages of creating the data product journey, or they are in advanced stages. Key major players in the healthcare industry, they are already into the different stages of adoptions. The reason is ever growing regulatory needs, data governance, and
Right.
increasing customer demands. How do you want to differentiate in your market? So I'll say 60 or 70% of your finance sector and healthcare are already into the journey, or they are in the advanced state.
Okay. All right. That's interesting because what I was thinking was the healthcare sector and the financial sector are two of the sectors which tend to move a little slowly, primarily because there is a lot of compliance requirements as well as legal requirements. I was under the impression that these two sectors would be slightly behind the curve, but then I'm surprised to hear that these are the two sectors which are actually in the forefront of this transformation in terms of technology. How is it that happening? Because the compliance requirements actually complicate many things for these two sectors specifically.
Yes. The reason is the data governance and a lot of regulatory needs are now more stringent. So, as I said, moving from centralized to domain ownership has become much more focused on those organizations. So, they want to do a specific domain focused analytical needs. That is where this evolvement has come. The regulatory driven nature, where they need to be mindful of the fines if there is a data breach, or if the reporting is not proper. There is a conscious attempt made by the say finance and healthcare industry to make sure data is, you create the data and this data speaks the same truth across different reporting system, and that is scalable, and they can be competitive in the market. That is what makes them drive to this stage.
Okay, that's interesting. All right, I think we've covered quite a bit in this discussion right now. Ravi, I think it's going to take a while for folks that watch this to absorb, process, and then think through many of these things. I think we're going to have many more sessions to come. But before we kind of wind this down, are there any other thoughts that you want to share around this?
As data lakehouse and product journeys are there, and there is a ever-growing need of generative AI. How do we manage those requirements? How do we create a data product that can be then fed into my large language models and all? Will be probably we'll discuss in our future sessions.
Certainly. I think LLM is one area which requires a very, very detailed discussion. LLM is a key thing in terms of how the data is being consumed and processed, etc. in the world of AI. We'll certainly touch upon that topic also very soon. I think we're almost out of time at this point. So those of you that are watching this, I hope that you found this to be useful. And both of us will be meeting you soon with a different topic, but once again related to the area of data, and then help you understand things better with the help of Patavi's insights. All right. Well,
Thanks.
thank you so much, Patavi, for your time. I appreciate it. I think it was a good discussion. And at least I learned a lot of things which I did not know in the last 40 minutes or so. And I also made some notes. I'm going to discuss that and take things forward with you also offline. All right.
Thanks.
Thank you so much. Have a nice day.
Thank
Bye bye.
you. Thank you.